Okay, this video will be talking about IBP, or integration by parts. So first things first, what is integration by parts? Integration by parts is a method used to solve integrals where two functions are being multiplied together. So it is basically the reverse of the product rule from derivatives. So we know the product rule, right? We know the product rule is the derivative of uv equals u derivative v plus uv derivative, right? So integration by parts comes from rearranging this. So the formula for integration by parts is u dv equals uv minus the integral of v du. So this is the main formula to memorize. It basically explains integration by parts in one line. The second thing I want to talk about is why do we even need integration by parts, right? So some integrals cannot be solved easily with normal rules. For example, we have this integral here, x e to the x dx. And we have a product. If you look closely, we have x times e to the x, right? So multiplying these functions together, it creates a problem. So IBP, it lets us move the derivative from one function onto another, and I'll explain what that means a bit later. Now I want to talk about the main idea of integration by parts. So when we see the integral of something times something of dx, we have to choose one thing to be u. So one of these somethings has to be u, and the other thing of the something has to be dv. And then what we do is we differentiate u, so it becomes du, and we have to integrate dv, so it becomes v. And then once we have these four components, 1, 2, 3, 4, we can plug it into our formula of uv minus the integral of v du. So the fourth thing I want to go over, and this is very, very important, is how do we even choose u and dv? Well, that's a great question. So in America, we learned something called LIAEC, LIAEC, I don't know, but it's this whatever euphemism, I don't know how to call it, but we learn LIAEC, and what it does is it tells us what should usually become u, and we go by highest priority first. So L stands for logarithm. So for example, ln of x is a logarithm, right? I stands for inverse trig. So for example, if we have tangent inverse of x, that is second to become u. A stands for algebra, so regular just algebraic variables we see, like these for examples. E stands for the exponent, like the exponential. So for example, e to the x is like the fourth thing that would usually become u. And then C stands for constant. It is the fifth thing that will usually become u. So this is just something to keep in handy. LIAEC, you might want to write it on your formula sheet for what comes first to become u. So since you're not doing trig examples, we can ignore the trigonometry here. So usually just the algebra goes with u and the exponential goes with dv is usually what you would see. The fifth thing I want to talk about is the IBP steps. So I want to give us an example that we kind of already looked at. X e to the x dx, right? So first things first, we pick a u and dv. As we know, the algebra comes first. So the algebraic part is the x. So u equals to x. And the leftover is what becomes dv. So dv equals e to the x dx. So now step 2 is we define du and v. So we differentiate the u part to find du. So that's just dx. There's an invisible 1 in the front that we can ignore. And then we integrate the dv part. So the integral of e to the x, as we've done a million times, is just e to the x. So now we can finally plug things into our formula, the uv minus the integral of v du. So then when we do that, it's the u times v, so x times e to the x minus the integral of v du. So this will become e to the x, and then du is just dx, so dx. Now we can just simplify and finish it off. So this is x e to the x. The integral of e to the x is just e to the x. But then remember, because it's like improper, we have to write a plus c. So then now, to really simplify it, we can factor the like term e to the x from both the terms. So this becomes x minus 1 plus c. So this is our whole answer. And look at that. We just did our first real problem of IBP. Now I want to go on to a bit harder problems that you're more likely to see on an exam, if anything. So problem number 1 I want to go over is find the integral of x squared e to the x dx. So again, choose u to be x squared because that's the algebraic component. And when u is x squared, dv has to be the other component, right? So dv equals e to the x dx. Now you can find the derivatives. So when we differentiate u, du becomes 2x dx. Remember to always write a dx after we finish finding our derivative of u, because it's with respect to x. So then we do it for the antiderivative of dv, which is going to be e to the x. Now we can finally apply IBP. So it's going to be u times v, or x squared e to the x minus v du. So e to the x times 2x dx. But would you look at that? Would you look at this second integral? This second integral requires IBP yet again, because we have something times something, right? But first, before I apply IBP to it, I'm going to factor this 2 out in front because it can be factored out as a coefficient. So this will become x squared e to the x minus 2 times the integral of e to the x times x dx, or x e to the x dx. Now we can look at the second IBP. So I'm going to clip and crop this. Okay, perfect. So for the integral of x e to the x dx, right, we have to choose our u, which will be x, and choose our dv, which will be e to the x. Now we can get our du, which is just dx, and our v, which is e to the x. And then we can apply it back, knowing that now we have the 4 components yet again. So then this can become x squared e to the x minus 2 times uv minus v du again. So then it becomes u times v is x e to the x minus the integral of e to the x dx. Now we have it a lot simpler. Now we can simplify, so this becomes x squared e to the x minus 2 times x e to the x minus, and the integral of e to the x is just e to the x plus c. Right, because always write a plus c for integrals. Now we can distribute the 2 to each term, right? So this will become x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And now what you can do is, because there's an e to the x in every 3 term, we can factor it out in front. So factor out e to the x. This becomes x squared minus 2x plus 2 plus c. And that is our simplified full answer to our first exam problem. So the main idea I want you to recognize with this problem is that we can apply IBP twice, because with this integral that we saw here, it's something times something, and that should scream immediately IBP. Now we're going to go on to our exam problem number 2, which is find the integral of x ln of x dx. So here we have x times ln of x. So we use IBP, right? And we can use the LIAEC thing I taught you before. So the logarithm comes first in LIAEC because that's what the L stands for. So this means that u should be the ln of x, and then dv should be the other part. So x dx is the other part. Now we can start differentiating. So the derivative of this, of ln of x, as we know, is 1 over x dx. And then the antiderivative of this, of dv, is x squared over 2. Now we can finally apply IBP because we have these 4 components, right? So IBP is uv minus v du. So we do u times v, which is ln of x times x squared over 2 minus the integral of v du. So minus the integral of x squared over 2 times 1 over x dx. So I'm going to clip and crop this first. But I want you to notice something in this integral. We notice that it can be simplified a bit. We can cross out this x and make this x a 1 because we're canceling out an x from each term. So we have ln of x times x squared over 2 minus the integral of x over 2 dx. Now what you notice is that x over 2 is the same as 1/2 x, and we can factor out the 1/2 out in front of the integral because it is our coefficient. So this becomes ln of x times x squared over 2 minus 1/2 of the integral of x dx. And I'm going to continue over here. This becomes ln of x times x squared over 2 minus 1/2, and the integral of x is x squared over 2. So we have x times x squared over 2 plus c. Remember the plus c. And now we can simplify this further by multiplying these two terms together. So we have ln of x times x squared over 2 minus x squared over 4 plus c. So this is our final answer. If you want to write it in like a bit neater form, you can put x squared over 2 out in front and like swap these two. But this is our final simplified answer for exam problem number 2. And this just practice having a logarithm in the integral. So that's it. And it's quite easy, to be honest. Okay. Now we're going to move on to exam problem number 3. This will probably be the last for this video. So find the integral of x cubed times e to the x dx. So this requires IBP because we have something times something, right? So we have to choose our u to be the algebraic expression first, which is x cubed. So u equals x cubed, and dv is whatever's left over. So dv equals e to the x dx. Then we can start differentiating. So du equals 3x squared dx. And then v will be the integral, which is just e to the x. Now we can apply IBP formula. So it's going to be u times v. So x cubed times e to the x minus v du. So minus e to the x times 3x squared dx. But wait, you can factor this 3 out in front because it becomes a coefficient. So this becomes x cubed e to the x minus 3 times x squared e to the x dx. But what you notice here is that this is another IBP because you have something by something. But luckily for us, and coincidentally, we have already done this problem, x squared e to the x. So we're just going to use what we had before, because we already solved the integral of x squared e to the x. So from earlier, we got that the integral of x squared e to the x equals e to the x times x squared minus 2x plus 2. That's what we got from our earlier result. So we're going to use it instead of redoing it all again. So this whole thing becomes x cubed e to the x minus 3 e to the x times x squared minus 2x plus 2. Now we can expand it by distributing this to all terms. So this becomes x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6e to the x. Now what you notice is that each term has a common e to the x, so we can factor it out in front. Oh wait, I forgot a plus c. Whoops. Always remember your plus c. Okay, so we can factor out the e to the x in front. Then it becomes x cubed minus 3x squared plus 6x minus 6 plus c. So this is our final answer to our third exam problem. And that's the last example I'm going to go over for now. What I want to go over for now is some common exam mistakes that I saw some of my students make, so you don't have to make the same mistakes again. So the first mistake is picking the wrong u. That's very bad. So let's just say we pick u equals e to the x for the integral of x e to the x dx. We have picked the wrong u. Why? Because when we differentiate e to the x, it does not make it simpler. When we differentiate our u, we want it to be simpler. So the good thing to do would be making u equal to x, because the derivative of that will just be 1, right? So it gets simpler. The second mistake is just completely misremembering the formula. So I saw some students make the formula uv plus the integral of v du. That is very, very bad and wrong. That is bad, because there should be a minus sign here instead of a plus. So the correct formula is uv minus the integral of v du. And then the third mistake I see students make is just forgetting the plus c. So to these kind of problems, always add a plus c. I know it's just silly, but everyone forgets it, even me, a lot of the time, so yeah. Now the last thing I want to go over is, when do we even know to use IBP? So we know to use IBP when we see, first things first, a polynomial times the exponential. So for example, when we see x e to the x, or x squared e to the x. So this is a polynomial times an exponential, so use it. Next is when we see a polynomial times a logarithm. So for example, x times ln of x, or x squared times ln of x. This is a polynomial times a logarithm, so use IBP. And the third thing is when we see a logarithm by itself. So for example, when we see the integral of ln of x dx and logarithm just by itself, use IBP. So we treat it as, what we treat this as is we treat it as ln of x times 1. So when we treat this as ln of x times 1, our u will be our logarithm because of LIAEC property rules. So our u will be our logarithm, and our dv will just be our dx, what's left over. So these are the three main cases in which you will have to use IBP on your exam. Now I'm going to provide you with a bit of a cheat sheet. So when we look at this formula, u dv equals uv minus the integral of v du, our steps are to first things first, pick u. Second thing, pick dv. Third thing, I will write this out. So first things first, pick u, then pick a dv, and then find our du, then find our v. Then when we have these four components, we can plug it into our formula, simplify, and add a plus c. So remember that make u simpler after differentiating. So when you do this process, our u should be simpler because our goal is to turn a different integral into an easier one. And that's it. That is all of integration by parts summed up. So yeah, well, I'm gonna go to Joe and the Juice. So